Welcome to Titan Environmental's GeoChat, the educational series that brings you the latest updates on geosynthetics and its applications in civil engineering, geotechnical engineering, and water resource management. I'm your host, Miranda, and I'm excited to share insights from industry experts on new processes, systems, and products that are transforming the way we approach geotechnical challenges. In each episode, we'll dive into different topics geared to civil construction products and engineering design and discuss their practical applications in the field. We'll also explore the latest research, case studies, and success stories from around the world. Whether you're a seasoned engineer or just starting your career in the industry, Titan's GeoChat is the series for you. Follow along as we uncover the latest innovations and trends in geosynthetics and learn how they can help us build a more sustainable and resilient world. Today, we're joined by Mike Rublaitus. Mike has over 25 years in the world of tunnel engineering, wastewater management, and concrete protection sectors. The products and installation principles he uses are increasing the lifespan of critical infrastructure, which results in cost savings. His visionary solutions have not only optimized efficiency, but also upheld environmental stewardship, ensuring cleaner, more sustainable futures for communities worldwide. So thanks for joining us today, Mike.
Thank you.
To get started, can you tell us more about embedded concrete protection liner?
Sure. So this would be an example of embedded concrete protection liner where you have a polyethylene or polypropylene surface on the front, and then on the back, you have anchors, and these anchors embed into the concrete. This particular type of embedded concrete protection liner is a little bit different than the early versions in the sense that these anchors are now in a grid pattern. What that grid pattern allows is that if there's any back pressure that hits the liner in pipe, for example, it will allow that water to divert around the anchors and it won't push the liner out of the wall. So when this is installed, the design life is the life of the structure.
Can you tell us more about how embedded concrete protection liner is crucial for the environment, human health, and the function of critical infrastructure in cities?
Sure. So there's really kind of two issues at play here. There's the aging critical infrastructure issue, and then there's the designing of sustainable infrastructure going forward. In many of the large cities, some of these structures, specifically manholes, could be 100, 150 years old. And over time, they become corroded out. They've developed either infiltration or exfiltration. And so the concrete protection liner in that area would go in, retrofit, and refurbish these existing systems. The other issue is going to be designing sustainable infrastructure systems for wastewater going forward. And with the concrete protection liner that we're using, it prevents corrosion, but then it also prevents infiltration. And so we're trying to achieve two things here. We're trying to protect the infrastructure, and we're trying to keep the environment safe and sustainable.
What are the key factors that threaten the integrity of wastewater management infrastructure?
So the main risk to infrastructure is going to be corrosion from hydrogen sulfide. And the way to mitigate that risk is to create a barrier between the concrete and the hydrogen sulfide. What happens is that bacteria will harbor into the concrete because it's very porous, and it creates an environment where that bacteria can live. As that bacteria dies off, that's what creates the corrosion in the system. When you use an embedded concrete protection liner, it presents a barrier where the bacteria cannot harbor. It cannot colonize inside of the plastic, and therefore the concrete doesn't get corroded over time.
So what is the best way to protect concrete in corrosive wastewater environments, such as pipe chambers, lift stations, and digester tanks?
So traditionally, spray coatings were the only technology available for that type of protection. And now some of the newer technologies are going to be an embedded concrete corrosion protection liner that's going to have anchors. And what's going to happen as this casts into the concrete, either on precast structures or poured in place structures or in rehabilitation applications, that concrete is going to cure around the anchor. The reason that's important is that that liner now becomes a permanent part of the structure. The design life is going to be the life of the structure, whereas with spray coatings or some of the older technologies, they continually needed to be replaced, and there were a lot of long-term maintenance costs to the owner. The concrete protection liner that we use primarily is going to be HDPE, or high-density polyethylene. High-density polyethylene is resistant to almost all waste streams or normal waste streams that you would see in a wastewater system. It gives you two forms of protection. It's going to protect against the microbial-induced corrosion, things like hydrogen sulfide that will eat the concrete away, and then it also protects against infiltration and inflow. It's the only technology that provides secondary containment in applications like manholes, pipe, chambers, and other types of concrete structures.
So how do embedded concrete protection liners differ from spray-applied coatings?
So with the spray-applied coating, you're going to get a surface bond, and that surface bond is going to coat the inside of the structure. The problem long-term is that when most technologies fail, they fail from back pressure. So there's going to be some sort of leak or corrosion that's occurring behind the surface, and that's going to start pushing that spray coating off. With concrete protection liners that are embedded or made out of polyethylene, they have the anchors on the back that are going to embed into the concrete and provide a permanent solution. Some of the other issues that you come in with spray coatings are going to be humidity. They have to be sprayed in certain conditions with low humidity. Many of them are going to require that you have a certain moisture content in your concrete, or less than a certain moisture content in your concrete. And that becomes especially challenging when you're working on retrofits or existing structures that need to be rehabilitated. It's very difficult in a manhole or in a chamber to go in and dry that system out to meet the manufacturer's requirements for spray coating. I think the biggest thing is that the spray coatings at some point are almost always going to need to be replaced over time, where the embedded HDPE liners are a long-term CPL solution and will last the design life, which is the life of the structure. They can handle back pressure. So if there was a leak, or if you're in the groundwater and we're getting some sort of infiltration pushing on the back of the liner, it prevents that leak from going into the system. They also provide a secondary containment at the joint or at the riser sections, so that if the gasket, in the case of pipe or a riser section, were to fail, you can still keep out the infiltration or the groundwater from getting into the system. With spray coatings, they have not been able to provide any resistance to back pressure and don't meet the industry standards for back pressure resistance.
Are there any no-dig options for using CPL to rehabilitate manholes?
That's a really good question, because in years past, up until recently, the only way to replace a manhole, for example, was to block off the street, maintain traffic, excavate, have trench box safety, replace the structure, and then recompact, and then possibly run a bypass. With some of the newer technologies like the Pretzel system that we're using here, there is truly a no-dig option. What you basically do, you're going to remove and open up the manhole, and we're going to do a 3D image, and we're going to scan the whole inside of that manhole. That 3D image also scans the base and the invert, which has been traditionally the hardest, most difficult thing to replace, because the base and the inverts are going to be larger than the opening at the top of the manhole. With the Pretel system, we're able to take that 3D image, put it onto a CNC machine, and create the reverse image out of styrofoam of the scan of the bottom of the manhole with the base and the inverts. We then take it, wrap it with some either high-density polyethylene or polypropylene plastic, and then spray the back with polyurea. When that styrofoam's removed, it allows that polyurea base to roll up and go down into the existing manhole. So we completely remove the base and completely remove the inverts in the existing manhole, and then install this new system. And then when we go vertical, we install the polyethylene or polypropylene plastic. We grout into place those anchors with a really high strength grout that cures within 15 to 20 minutes. And then we're able to rehabilitate a manhole in less than a day in most cases.
How does embedded concrete protection liner differ from other no-dig CPL options?
There's really very few, if any, other no-dig options. There's some other systems that claim to be no-dig, but with those systems, you still have to replace and dig out the pavement around the ring and the cover. You have to remove the cone, and you have to re-pour that, recompact, and then replace the pavement that was disturbed. With this option, it's a true no-dig option where the street or the surface is not disturbed at all. There is nothing at all that needs to be excavated. Everything is done inside the manhole. And again, this is usually completed within a day.
Can you tell us more about Titan's prefabrication and installation service for CPL applications?
Sure. So in the example of a retrofit, for example, we would go in, when we do that 3D scan, we then have all the parts made off-site for that system. Then we will take those parts out to the job site or out to the manhole, and it acts as a plug-and-play system. There's no field measuring like there is with other systems. Everything is cut to precision and ready to install. Many of the other systems out there, you would need to lay out your liner. You need to fabricate on site. And the result of that is it takes much longer to rehabilitate a manhole than it would with Titan's system of coming out with everything prefabricated and ready to install.
So how long does it take to rehabilitate a manhole, and how many people are needed?
When we use the Pretel system, we only need 2 people per manhole. And with that 2-person crew, we can rehabilitate that manhole in a day or less. Where this differs from some of the other rehabilitation methods is that they have to pour traditional concrete, wait for it to cure, then strip their forms, and then go back in and weld. With the Pretel system, it operates much quicker, much easier, and much faster. What happens is the crew will go down in there, they'll remove the base, they'll put the new base in, and using the quick set grout, usually that grout can set in 15 to 20 minutes. So this grout, compared to traditional concrete, will set much faster, allowing the welding to take place in the same day, and most manholes can be rehabilitated in less than 6 to 8 hours.
And can you tell us more about the Pretel manhole rehabilitation system?
Sure. So the Pretel system is a no-dig rehabilitation system of manholes. For example, if you're in a major metropolitan area where you cannot dig up a manhole, or another example would be a manhole in the middle of a highway where it's not feasible to dig up the manhole, this is a no-dig option where we can go in and rehabilitate the manhole in less than a day. And simply put, we take the base out. We have a flexible base that we roll in. We install and grout that base into place. And then on the vertical riser sections, we have a high strength grout that we put behind the liner, and we grout in place a brand new high density polyethylene or polypropylene lining system. That gives you a permanent structure and a permanent rehabilitation of the manhole.
So that is all we have for today. Thank you for joining us, Mike. Your insights and expertise are greatly appreciated. And for anyone looking to discuss a wastewater management project, you can find Mike on LinkedIn or contact him through the Titan Environmental website. If you're interested in learning more about industry-specific products, designs, or applications, visit titanenviro.com to browse our full library of videos, case studies, and more. And thanks again for tuning in, everyone.